So graphs are informally collections of objects and together with the connections between them. So for example, we might have things called A, B, C, D, E and F, so 6 objects, and the connections between them we might talk about. A is connected to B in some fashion, A is connected to D, let's say A is connected to F, C is connected to F, D is connected to E, C is connected to E, let's see, maybe B and F are connected that way, and maybe also B and D are connected that way. So the idea is that these could be computers or nodes in a network, and either the computers or the nodes talking to each other directly, so A talks to B directly, or there might be a physical connection, but A doesn't talk to C directly. A could talk to C via D and E and C. Or these could be towns, so in this case the connections could represent the roads between them. So then a little bit more formally, the things, the objects that are being connected we call vertices. So in this case we've got 6 of them, A, B, C, D, E and F. And the connections we call edges. So we'll actually give them some names here. So let's call this edge E1, let's call this E2, E3, E4, E5 is the one going from F to C, E6, E7 and E8. So this graph, which is just a collection of the things A, B, C, D, E and F, have vertices A, B, C, D, E and F, and the edges E1 through E8. You can have other sorts of edges, for example, F might be joined to itself. I don't know why a node would want to talk to itself, but it's a possibility, so let's add that one in and call it E9. It's possible that there might be 2 connections between 2 objects, so D and E as E8, but there might also be another one around there. So we up to E10. Okay, sometimes when it's completely unambiguous as to what we talk about, but we use some fairly obvious notation. So for example, E1 connects B and F, so we might abbreviate that just as the edge BF. And when you see B and F together, you know that that's what you mean, that it's the only thing that it could mean. Then E2 is the edge joining A and F, so we could informally write it AF. E3 is the edge joining A and B, so informally we could call it AB, and keep on going like that. So sometimes we'll label the edges E1 through to whatever, and sometimes we'll talk about the endpoints that are at the end of the connection. So B and F are at the endpoints of edge E1. These sorts of things here, where we've got E8 and E9, E10, those are called multiple edges. By and large, we probably won't be terribly interested in multiple edges, and these things are called loops for fairly obvious reasons. We won't be so much interested in them this time round, but they are important. Now a little bit of more terminology. graphs come in various sorts of shapes. So you can see in this graph that if I start at A, then I can get to any other vertex on the graph by following a sequence of edges. So if I want to get to F, well, I could go to F directly, or I could go from A to B around to F, or I can go from A to B to D, around to E to C to F. That's quite a circuitous route, but it's a possibility. And I can get from anywhere to anywhere else. But sometimes graphs come in pieces. So for example, we might have something like this, A, B, C, let's make it D, E, F, and G. So here's a graph where I'm thinking of it as all the vertices are A, B, C, D, E, F, and G, and all the edges are from A, B, D, B, C, sorry, A, D, B, D, A, C, E, F, G, F. So this is a single thing, but you can see that it comes in two pieces. And the idea is that if you start at A, there's no way of getting over to E. There's no connection over to this component. So the difference here is that this whole thing is a single graph, but it comes in two pieces, or more strictly two components. So in this case, because you can't get from one piece or one component to the other component, we call it a disconnected graph, because it's not connected. Something like this is connected because it's really just in one piece. So you can think of it as one component. Again, the big idea with these components is that if it's a connected graph, then there's a way of getting from every vertex to every other vertex. There might be more than one way, but there's at least one way. And since we're talking about getting from one vertex to another vertex, we can think about things called paths. So let's give this let's give this graph a name. Let's call this G. So in the graph G, we can talk about a path, and a path simply means that we're going to start at a vertex. So pick your favorite vertex, or let's say B, and then we're going to travel along certain edges and keep on going. And the idea is that we're not going to repeat any vertices or edges. So let's say we go from B to A via E3. So we're going to list the vertex edges in turn, so alternate them. So path B goes via E3 to A, then we might go to E2 to F, then via E5 to C, and then let's say we go to E6 via E6 to E. 6 to E. We can then talk about the length, and we basically ask ourselves, well, how many edges are involved? So 1, 2, 3, 4 edges. So we're basically counting the number of edges involved. And notice that in this path, we're not repeating anything, so we're not going something like A to B, around to E to F, and then back again, because that would then actually close off. That actually is then called a cycle, so we're going to look at that in a little while. So path, start somewhere, keep following an edge to a new vertex, follow another edge to a new vertex, etc., etc. and we count the number of edges as being the length. So a cycle is a very similar sorts of thing. May as well do the one we just did. So if we start at B again, we go around E1 to F. Oh, actually, let's be a bit more adventurous. Go around to E. Let's follow E2 up to A, then E4 down to D, then around E7 back to B. So you notice that the start and end point are the same. Sometimes we can abbreviate this simply as B, F, A, D, and back to B. And in this particular case, because there are no multiple edges involved, you don't have a choice here, like here. There's only one edge between B and F, between F and A, etc. It's clear what's meant. Same thing with the path. You could actually have abbreviated this path as simply being B, A, E, F, C, and ending at E. Again, we can count the number of edges in the cycle, and in this particular case we've got 1, 2, 3, 4 edges as well. So we've got 1, 2, 3, 4 edges. We call this thing, if it's got 4 edges in it, we can call this a 4 cycle. So calling it a 4 cycle simply says it's a cycle and it has 4 edges in it. What does a 1 cycle look like? Well, a 1 cycle is simply a loop, F, going around edge E9 back to F. So a 1 cycle, example, F, follow edge E9 around and end up with F. That's we're only using one edge. A 2 cycle in this graph could be involving D and E. So we start at D, follow E8 around to E, and then follow E10 back around to D. So start at D, end at D, and we've used 2 edges. Of course, as I said, this thing is basically a loop, which is exactly what that E9 looks like. Here, E8 and E10 we sometimes call them parallel edges, or multiple edges. Some notation sometimes used.